Skill trees are a part of a lot of games these days, and they may seem intimidating to make in your own games. But in this video, I will show you how to make a skill tree where you can put different skills and like a chain of unlocks in which you can unlock them and eventually get those crazy skills at the end of the day. So I'll be showing you a lot of server client interaction, the basics of graph theory, because skill trees are little graphs, and graphs are really important for computer science down the line if you want to get involved in it, and just some like GUI interaction stuff as well. This is a pretty advanced video and it's a pretty long video, but trust me, you can get through it. And it'll be really cool at the end to see your finalized skill tree that you can put in your own game. This is a really important video. It covers a bunch of different concepts that I think are pretty important to your development career and career as a computer scientist. So I would recommend that you watch the entire thing and maybe learn something from it. And if you do, make sure to like the video, subscribe to my channel for more advanced Roblox scripting videos like this. And without further ado, let's get started. A skill tree in its most basic form is a graph. And a graph is just a set of nodes or vertices, they can be called a bunch of different things, connected by some edges. So in our case, in our skill tree, these edges are going to be directed. And directed means that there's going to be like an arrow going from one node to another. So this can be an example of a graph. We can label it like A, B, and C. And so thinking of a skill tree like a graph gives us a lot of different tools to help us reason about it. Because for one, when you think about like normally, like this is a pretty easy relationship to talk about. This is like, A leads to B, B leads to C, and like that makes sense. But what happens when you have something like D and then maybe like E down here? And let's say that A points to E and then E points to D, but C also points to D. Now, this relationship is a little harder to reason about, but luckily, by using graphs, it makes everything pretty trivial. So, our plan for this skill tree is to create a graph where basically each of the skills is our nodes and each of the edges is like the prerequisites to unlock it. So, for example, to unlock skill D, you're going to need both E and C, and these arrows kind of tell you what these are. So now let's go into the code and kind of graph this whole idea out. So now I'm in Roblox Studio with a project setup. Now the only important thing you need to note is that I already have a skill tree GUI in my project with a skill tree here. Let me make it visible. This is just a picture. It's an image label. And there's a couple other aspects to it that I'll talk about a little bit later. But basically, this is like an elemental skill tree. So you have like the base. This is the base like root of the tree, and then you got water and fire, and water points to ice, and water also points to steam. I know this is a horribly drawn steam icon. I did it myself. That's the issue, but don't mind it. And then steam leads to smoke. Now this relationship is kind of contrived. Like in an actual skill tree, you'd probably want something a little bit smarter, but for demonstration purposes, this should work. Now, I was thinking about making a script to procedurally generate this kind of image, but upon my research, most skill trees seem to be like hand drawn, and I think that's kind of like how most people would prefer it to happen. So I'm gonna leave it like that. But if you guys would like to see a way to procedurally like generate this sort of skill tree, then let me know. But it definitely deserves its own video. But for now, make yourself some sort of like image or whatever to represent your skill tree and make the relationships, then we can get going. So going back to service script service, we're going to make a module script. And this is going to be our skill tree info. So this module script, I'm going to delete everything inside of it. What it's basically going to be is just kind of like a reference to the information pertaining to our skill tree. So all we're going to do is we're going to return a table, and this table is going to contain all of like the stuff that we need for our tree. So the first one I'm going to do is fire. So fire, I'm just going to say cost 3 points. So points equals 3. And then the prerequisites. So prereqs meaning like the things that you have to unlock before getting it. So if you've ever taken like classes that require prerequisites, this is what I'm referring to. So this will have no prereqs. So each of our skills is going to have a points value, which is how many skill points it'll take to unlock, and we'll implement that in just a second, like skill points. And then it'll also have a list of prereqs. So this is fire, and then so you can see fire takes nothing because this is going to be unlocked by default. We're just going to assume this is unlocked by default. And then we need to graph out the rest of these. Now, this is kind of like a verbose process. So I'm going to go yoink my stuff from another screen and put it on here. So this is all you need. And I will have all the code in the description so you guys can check it out if need be. But when you make a skill with a prerequisite, inside of the list, you put a string with the name. Make sure this name matches the name of the actual like entry exactly. So this water matches this water up here. This steam matches this steam up here. So this is how you'll define your skill tree. And we're doing this in a separate file so that maybe like someone who doesn't actually code, who's like a game balancer, can tweak these values as they see fit. But keep in mind that like if you change the prereqs, you're probably going to change the actual image for the skill tree. But it's good to keep this in a separate file. This almost acts like a JSON file if you've done like web development before, and it looks pretty similar too. So this is all done. Also note that the trailing comma after this doesn't actually matter. You can have it, you can not have it. It's up to you. Really, you should have it. It's better practice. But at the end of the day, it don't really matter. Okay, so let's go to our server script service again, and we can make a script. And I guess we can name this script this skill tree. What this will have is first we're going to start by setting up our player, because every player when they join our game is going to have a set amount of skill points, and you can obviously tweak this to your game as you see fit. But for this example, as I want a complete example that actually works out of the box, we're going to set it up ourselves. So first things first, we're actually going to have to get our skill tree info module script by saying require script.parent.skilltree. So then we also need to say local players equals game get service players. There we go. Because when each player joins, we're going to set up their leader stats to make the skill points. So this is a basic, pattern in Roblox where we hook our player added to a new function. And in this function, we're going to say local leader stats equals instance.new folder. And then leader stats.name is going to be equal to leader stats. And then leader stats.parent is going to be equal to player. So what this will do is this will make a leader stats folder in our player, and that means any value that we add to this will appear in the leaderboard in the top right, and I'll show you that in just a second. But for now, let's create our skill points by saying local skill points equals instance.new int value, and then we'll say skill points dot name equals skill points, and just name it whatever. And we're going to do skill points dot value. And then for the value, like in an actual game, you set it 0 and you get skill points through like killing enemies or whatnot. But for us, we're going to set it to 100 because I want skill points to start out so I can actually spend them. But keep that in mind for your own game. We're also going to set skill points.parent equal to leader stats. And then there we go. So we have the leader stats set up. Let's just double check that they work. Oh, well, they don't work because we required with invalid arguments. It's skill tree info up here. Don't get me wrong, because the skill tree info is module script. The skill tree is our actual script. So let's run it again. We have 100 skill points in the top right. That's why we put in leader stats. Okay, we have that. But also, in addition to our skill points, we're going to need something to actually store the skills. So I'm going to be storing the skills in a... So each player is going to have their skills stored in a global table. That's going to be called player skills equals a blank table. Now, in an actual game, you would like this to be some sort of data store, or like connected to your data store somehow, so it saves between sessions. But for us, that's outside the scope of this video. If you want to see how to hook it up to a data store, just let me know. I also have a data store video that you can check out, although it might be a little outdated at this point. But there are good resources that on the forum that I'll also put in the description for you to use. but we can say player skills brackets player.userid is equal to a blank list. So what this does is every time a player joins the game, it initializes their skills to a blank list. And this means later down the line when we're trying to add skills to the player, and the skills will be in the form of just like a list of strings, we can just do that. Also, if you plan to change the name of your skills, I would recommend also having like an ID in here, which is set to a number that you can change down the line. But for us, since this is small and like we know what our skills are, we're just gonna leave it as a name. It just makes the code a little simpler, but it should be relatively easy to adapt if you do that. Okay, so now we have the setup done. Let's start making like the interaction between the server and client. And the first thing we're gonna do is create a remote function in replicated storage that's going to be called get skill tree info. So what this is going to do is it's going to get each player's individual skill tree info. Because keep in mind, if you have unlocked a skill, like there's really nothing to do on the client. Like the client doesn't need that extra information. So we're going to first start by making, or I guess first we need to get our skill tree info reference. So we're going to say local get skill tree info equals game get service replicated storage dot skill tree info. There we go. So since this is a remote function, we need the client's going to be like wanting to retrieve a value. That's why we use a remote function. So we're going to say get skill tree info dot on server invoke is going to equal a function with the player. So notice how this is on server invoke equals because this is a remote function, not a remote event, because we want to return a value. That's the reason we're using a remote function. So inside of here, we want to first get the player skills. So the player's currently like owned skills are going to be equal to player skills player.userid because like this table is going to have a list of skills for each player keyed by their user ID. And below that, we're going to say local player skill info is going to be equal to nothing. This is what we're going to populate to fill with all of the remaining skills that the player needs to unlock and their prerequisites. So we're basically be copying, like selectively copying the stuff from this list that they need because we don't need to send them extra information. So we're going to say for name info in skill tree info. Notice how we don't need to do pairs or iPairs. That's old now. Luau allows you to do this, which is pretty cool. We can say if not table.find skills name do or then we can say player skill info brackets name equals info. So what we're doing here is if we don't find like for example, if we don't find fire in the list of player skills, then we can add it to their own skill info keyed by the name, and the info is like just copying this stuff here because this is the name, this is the info. You can copy that there to them in this new table, and then we're just going to return this new table. Return player skill info. There we go. So then on the client side, we're going to want to create a new script or a new local script. I'm going to call this local skill tree. And then in here, we're going to get a couple of things. So the way I have my setup is we have a skill tree toggle button, which is parented directly to GUI. We have a skill tree image label, which has the image in it. Then we have an unlock button parented to that. And then inside of this, we have the folder of node selectors. These are buttons that are on top of the actual thing. So when I make them visible, see how they dim out the skills? This will kind of be like the visual indicator to the player that like this skill is not unlocked, you didn't unlock it. So my goal here is like when you click on the like dimmed out button, it's going to change the text of this unlock button down here. And when you unlock it, it's just going to make it invisible. So that should be what we want to do. And I also have this UI ratio aspect ratio constraint for the image label because, so it scales. It's not perfect because this each of these buttons has a UI corner, so if you see, like, it's not a true circle, but Imma be honest, I don't really care that much. Having a almost circle is good enough. I like the effect, it's good enough. So the goal here is, depending on the information we get from the server, we want to return, or we want to, like, edit which ones are visible, which ones are invisible based on which ones are unlocked, and then also change the way, or, like, what the buttons do. Because when this goes invisible, we want to, like, make the button inert so it doesn't actually do anything. So let's get this in code so you can stop hearing me yapping and start seeing actual code be put to use. So we're also going to make this skill tree thing invisible by default because we're going to click on this button to unlock it. So we're going to start by getting the frame. So the skill tree frame, which is equal to script dot parent dot skill tree. And then we're going to say local node selector. Actually, it's not really a frame. It's probably an image label. Whatever. It's the same thing. I can call it a frame. So we're going to say local node selectors equals skill tree frame. Wait for child. Actually, no. Skill tree frame dot node selectors. And then local unlock button equals skill tree frame dot unlock button. And then the skill tree toggle will be equal to script dot parent wait for child skill tree toggle. So just to be safe, we're going to change the skill tree frame to be a wait for child. Not sure if it's needed, but we're going to do it just in case. And then we're also going to get the get skill tree info. Oh my god, this is a mouthful. Function from replicated storage. So game get service replicated storage dot get skill tree info. There we go. So we got all the stuff that we need for our client, because we're going to need an unlock button later. Node selectors is just a folder of all of the buttons that are like the little gray pieces. So I guess let me make it a little more clear. If you're not sure what I'm talking about, the node selectors are just the gray portion, like the semi-visible portion on top of the GUI. And again, this stuff will be in the description so you can play around with it. I know it's a lot, but I want to get to the actual coding content. That's more important. The GUI does take a while to make. It's kind of annoying, but like it's pretty simple. So we're going to start by defining the local player skill tree inflow, which is going to be the table that we're going to get from the server. And then we're going to define our current selection, which is going to be equal to nil, depending on like which skill we have selected. So you're going to select a skill, and the unlock button will reflect how much it costs and what skill it is. And then now we're going to say skill tree toggle dot activated, connect a function. And here, this is going to be where we flick on and off the GUI for the skill tree stuff. We click this and the like menu appears. And so we're going to say if not skill tree frame dot visible, then we're going to like set it up. And then otherwise we're going to like clean it up. But at the end of the day, for both of these branches, we're going to set skill tree frame dot visible equal to not skill tree frame dot visible. So this will toggle the visibility of our frame. So if it's not visible, we want to do like the setup stuff for the skill tree. So I'm going to make a local function, say local function set up skill tree. It's going to have no parameters. And in here, first of all, we're going to retrieve the skill info from the server by saying get skill tree info, invoke server. That's all we need to do. And this will retrieve our local player's skill tree info, which is great. And then we're going to run through name info and player skill info, just like we did on the server. But here, what we're going to do is we're going to get the selector. So notice how in the folder of node selectors, I named each of these exactly the same as I did on the server with the like names up here. And that's purposeful because they cover the thing that you're dealing with on the client, like just the local like image stuff. So we're going to say node selectors. We're going to say local selector equals node selectors wait for child name. So we're gonna find the thing, and then we're gonna set selector dot visible equal to true, because if it's if it's in the player skill info, like, it's not unlocked, so we need to cover it up with that selector button. And also, we need to do selector.activated, connect a function where we're going to, like, once our selector is clicked, we're gonna set the current selection equal to the name. So the current selection is a string. It's just gonna be the name of the currently selected skill, and we're also gonna reflect that in the unlock button. We're gonna say unlock button dot text equals string dot format. I'm just using string dot format to make concatenation easier. We're gonna say unlock or percent sign s. And I'm gonna do percent sign I points. So, and then we're gonna pass in name and then info dot points. So what we're doing here is string dot format just takes in like this little percent sign means like a parameter is gonna replace this. So the name is going to replace our this thing right here, and the I means like it's an integer, so like for numbers and stuff. So this little info dot points is gonna replace this uh percent I kind of thing here. And then we're doing info dot points. That's gonna be this value right here. So it's gonna be like, all this stuff here. And yeah, so this should work out just fine. But look at how we're creating a new hook event connection every single time we open up our panel. Well, we are when we run this. So when we run this function in every single activation, we're creating a new connection. That's a memory leak. We don't want that. So we're going to have to make a list of connections. So we're going to say selector connections equals a blank table. And then, oh, I spelled selector down here. That's interesting. There we go. We fixed that. But before this activated, we want to say selector connections name equals this. So it'll add our connection to this list. And then once we're done, so if it is visible and we're closing it, we want to get rid of all of those connections. So we're going to run through all of them. We're going to say for underscore con in selector connections do con disconnect. And then we're going to call table.clear on the selector connections. So what we're doing here is basically just disconnecting all of our connections because we don't want a memory leak. We don't want these running and being able to click in the background, and it'll cause a whole bunch of issues. We don't want that. So we clean this up when we close it. And realistically, we don't have to do this at every single opening and closing of the GUI, but just for in case something goes wrong, you want to just start fresh from the server, you can just do this, which I think is a good strategy just to make sure every time you open and close it, it'll be good to go. So now we should be able to try it out. Let's see how it goes. Okay, so we click this. Oh, I didn't get it. I spelled activated wrong. That is tough. Let's go back and fix it. There we go. Remember to spell correctly, kids. And we click this. We get it. And we click on different things so we can see it has all of the stuff. So when we click on each button or each little shroud on top of our skill, it changes the text to the unlock thing, and it all works out in the end. Cool. Now the next step is to actually make the unlock button do something. So below our toggle, we're going to say unlock button activated, connect a function. And then first of all, we're going to say if not current selection, then return, because if we have nothing selected, we obviously can't really unlock it. So how are we going to do the unlock stuff? So for that, we're going to make a new, why am I trying to rename replicated storage? A new remote function, and this is going to be named try unlock skill. So this is a remote function because we're going to return a Boolean, it's like success, which is going to say whether or not the unlock was actually successful. So the client's going to go petition the server and say, hey, let's try to unlock this. And servers are like, okay, we'll see. And I will say, okay, return true, it was good, successful, return false if it's not successful. So we're going to first get it up top. We're going to say local try unlock skill is going to be equal to game get service or replicate storage try unlock skill. Cool. And then we're going to say local success equals try unlock skill, invoke server, and we're going to send it the current selection. So we're going to say, hey, we're going to try to unlock this current selection, this string here, and then it's going to give us a success boolean. I'm going to say if it's successful, then we're going to say node selectors current selection dot visible equals false, and then we're going to say selector connections current selection disconnect. So what we're doing here is if it's successful, we take that specific node selector. So let's just say we unlock fire. Let's make this visible. We unlock fire and like, okay, we unlock fire, but we don't need the shroud over it anymore. So we just delete that selector, or we don't delete it. We make it invisible, and then we disconnect the connection so that we can't click it and update the button any longer. You could, I guess, delete it, but I mean, I don't know. It's just like more destructive. This is simpler. It can lead if there's like an issue or something down the line, like the GUI will still work in the long run, even though I don't think a skill unlock should ever be revoked in a game. But you know, this is just a better habit to get into, I'd say. So now we did this, but now we need to implement this in the server. So let's go to our server script, and then up the top, we obviously need to get it from replicated storage. So try unlock skill will be equal to game get service, replicated storage, try unlock skill. There we go. Now we need to say try unlock skill dot on server invoke and equal to a function which takes in the player, and now we also have another parameter, the skill name, which is going to be a string. So first off, we need to double check if the skill name exists. So if not skill name, then return. This is just a good practice since we don't really know what the client will send to this because exploiters could like send some junk to it. We want to make sure like if it doesn't exist, if skill name like doesn't exist, then we just kill it off the bat. Otherwise, we're going to say local leader stats equals player and player find first child leader stats. So this is another like defensive coding strategy. We need to make sure the player exists, and then we also need to check if leader stats exist using find first child. We don't know, like something could have happened where it got deleted or like whatever. We're gonna say local skill points equals leader stats and leader stats find first child. That is not what I want to do. Find first child. Skill points, and make sure this string in this find first child is the same as this one up here. It'd be good to make a constant, but you know, whatever. So why we're using and here is because this and returns the first argument if it's false, or the second one if it's true. So, and true and false in this case means exists. So if the player exists, or if the player doesn't exist, we return nothing. And then if leader stats doesn't exist, we return like false or nil. And then if it does exist, we return this, and we go here, and then we go here. So it's just like basically little tiny if statements, if else statements with like nil and stuff, but it's just simpler and like pleasing to the eye to put it this way. And we're also going to do the same thing for cost. Like how many skill points will this cost? And it's going to be equal to skill tree info, skill name, and skill tree info, skill name, dot points. So theoretically, actually with this line, I think this actually might be a little better. Since we're checking for skill tree info, skill name, if skill name is nil, this actually won't give us anything and it'll short circuit. So actually no, it's good now. We can just delete this guard clause up here because, you know, we already handle it with this kind of like check here. And you'll see why this is handled in a second when we make the if statement. But this is just the cost of number of skill points that are skill costs. So we're going to say if skill points and cost. So this cost also means that like skill tree info.name is, or skill tree info skill name, it actually exists. So this assumes this, and you could obviously like replace that too. But so we have the skill points and the cost. Then we can like do something, but we need to do some other checks before that. So we need to make sure and I'm making a space here just because you'll see. we're going to say and skill points dot value is greater than or equal to cost. And this will make sure that our skill points, our current skill points, like the skill points of the player, is greater than or equal to cost. And we also need to make sure that the skill that they're trying to unlock has the prerequisites satisfied. So we need to do and satisfy prereqs, which will pass in the player and the skill tree info, skill name dot prereqs. Prereqs. There you go. So we need to make this function satisfy prereqs. It's going to be a local function. And all we're going to be basically doing here is player prereqs is going through the skills of the, or going through the prereqs and then making sure it's in the player skills. So we're going to get our player skills first. Equal to local skills is going to be equal to player skills player dot user ID. And then we're going to say for underscore name in prereqs do. We just use the underscore here, by the way, just because we don't care about the first value. That's just the iteration number. Say if not table.find skills name, then return false. And then if we get through it without returning false, we return true. So if we don't find the actual skill in the prereq in our player skill, so if the player does not have this prereq, then we instantly abort. We say, hey, you can't get this, return false. And then otherwise, if all of these get through without triggering this return, we just return true by default. So now we say if skill points and costs, if and it satisfies the cost thing, and we satisfy our prereqs. We all satisfy all these things. All these things exist. Everything is good. And by the way, this skill tree info skill name is guaranteed, or prereqs are guaranteed to exist because cost exists. You can make it more explicit by replacing this little block here down here, but it's more characters. I don't know. Do what you want. But in this if statement, we can say if not table.find player. Actually, we could add this to our big if statement. We can say and not table.find player skills player.user ID skill name. So this accounts for the case where the player owns the skill. If they own the skill, we don't want to charge them twice. So if the player doesn't already own the skill, then we go down here and we say skill points dot value minus equals cost. So we deduct cost from the current player skill points. We add that. So we do table.insert player skills player.user ID skill name. So we add the skill name to our list of skills that the player has, and then we return true because it was successful. And if all of this fails, we return false. So, sorry for the confusion up here. I just realized I could simplify my code further. So we have to satisfy all of these requirements to get to the point where we can actually deduct our points and then like do the insertion. So this adds the skill to this little table that we created earlier up here. So now we have all this. All that's left to do is try it out, I guess. Let's do it. Okay, skill tree, open, boom. Fire, cost 3 points. Unlock this. Boom, 3 points is deducted. That's great. Okay, let's say we want to unlock smoke. We can't do it. It won't let us. It keeps on returning false, and because we don't have the satisfied prerequisites. And here we can try to unlock water. That works. Unlock steam. There we go. Unlock smoke. Boom. And then if we open and close it again, you see there is no shroud over it again. We can unlock ice. There we go. That is absolutely wonderful. And obviously, like we still have this unlock ice. Like you can polish this up to as much as you wish. But I hope I provided you the building blocks for your own skill tree system in your game. And I know I felt I was talking pretty fast in this video, but there's a lot of content to get through, and this is still like 30 minutes long, which is kind of crazy. But there could be more like offshoot videos off of this. So if you want to see something else, like maybe making a procedurally generated skill tree, like visualization instead of using like the image that I use today, or something else along the likes of that, then just let me know. But comment any questions. The code will be in the description. And make sure to like and subscribe if you enjoy. And with that, I hope you have a nice day and goodbye.